Hey, Algebra 2 students. So we're going to pick up with example 4. Hopefully you've tried it. As you can see, I don't have a Coke. I had mini Cokes. I tried 3 times to make this next video, only to find out nothing was working. Went home, probably should have had a good cry, didn't. Instead, took a nap. Now I'm back. Sweet tea. Gonna try it again. Let's get going. Hopefully you've already tried example 4. So let's see how you did. Remember, with an inverse, we're gonna switch our x and our y. So I have x equals y squared plus 1. I want to get it to where I have 0 on one side because this is a quadratic equation. So I'm gonna subtract the x over. So I have 0 equals y squared plus 1 minus x. And let's talk about our values for a, b, and c that we need to plug into the quadratic formula. So a comes from your coefficient in front of the y squared. And so in our case, a is going to be 1. B, this one might have been a little bit tricky actually. B comes from your coefficient that's in front of the y to the first power. But if you look up here, we don't have a y to the first power at all. So our value for b is going to be 0, which means that our constant is going to be this entire thing back here of 1 minus x. Remember, we said for these type of problems, because y, we're considering that as our variable, x is just representing some numeric value. So the entire 1 minus x becomes our constant value for c. So if you need to pause this for a minute and do some erasing, go ahead and do that. But we're going to pick right on back up with using our quadratic formula here. So we're going to do opposite of b. Well, if b is 0, and 0 can't be positive or negative, it's just 0. So 0 plus or minus the square root of b squared minus 4 times a times c. And all of that is going to be over 2 times a. So I'm not going to write the 0 out front. It's not really there. I've got the plus or minus. Then I have the square root. 0 squared is just going to be 0. It's not there anymore either. And so I have negative 4 times 1 minus x. So let's go ahead and multiply negative 4 times 1. That's going to give us a negative 4. And that negative 4 gets to be distributed to the 1 minus x. But let's talk about this for just a moment. If you remember in the last example, we had a GCF that we took out. It was a 4. And once we took that GCF out, because it was underneath the radical and it was a factor, it came out of the radical and turned into a 2. So I've got a 4, which is already outside of the parentheses. So rather than distribute the 4 into the parentheses, let's leave the 4 on the outside of the parentheses, but that negative that's with the 4, let's go ahead and distribute that. So we're going to distribute that negative sign into the 1 minus x. It's going to turn that into a negative 1 plus x, which you can write just like that. I'm going to rewrite it though because I kind of like the way x minus 1 looks. I like it a little bit better than negative 1 plus x, but you can write it whichever way you want. And then we're going to have all of that over 2. And now we get to take this factor of 4 that's underneath the radical. It's its time to shine because it's a perfect square. So we get to take out a 2. So we have y equals plus or minus 2 onto the square root of x minus 1 all over 2. And we see that we have a factor of 2 in both the top and bottom. And they're going to cancel each other out because they're going to divide away. And so we're left with y equals plus or minus the square root of x minus 1. And that's going to be our inverse function. All right, so we've got our inverse function. Now we need to graph. So I'm going back to my original equation. And in the last problem, I factored it first because then I could find my x-intercepts. But this doesn't factor. So let's think about what we know. If we just had y equals x squared and we didn't have that plus 1, we know that that's just going to be your basic parabola. It's right there at the origin. But the plus 1, if we go back to what we know about transformations, that plus 1 is going to represent a vertical transformation that's going to take our parabola and just move it up one space. So I'm going to create a table of values, and I'm going to kind of keep it centered around the origin, keep my numbers small. So I'm going to plug in a couple of negative numbers, I'm going to plug in a 0, and then I'm going to plug in a couple of positive numbers as well. So here we go. Negative 2 squared is 4, and 4 plus 1 is 5. Negative 1 squared is 1, plus 1 is 2. 0 squared is 0, and plus 1 is 1. 1 squared is 1, plus 1 is 2. And 2 squared is 4, plus 1 is 5. So let's go ahead and label the x and the y axis. So we have negative 2, comma 5, negative 1, comma 2, 0, comma 1, 1, comma 2, and 2, comma 5. So we absolutely get that parabola that we just talked about, that we said is your basic parabola. It's been moved up 1 unit because it was a vertical translation. So now is what I like to think of as the easy part, because now we're going to graph the inverse. So remember we did in the last example, we took all of the values from our table of values, and remember inverse just means you're going to flip your x and your y. So instead of negative 2, comma 5, we have 5, comma negative 2. Then we're going to have 2, comma negative 1, 1, comma 0, 2, comma 1, and 5, comma 2. And then let's graph it and see what happens. Remember in the last example we did, example number 3, we got a sideways parabola. Let's see if the same thing holds true for this one. So I've already graphed 5, negative 2, 2, negative 1. Now I'm at 1, comma 0, 2, comma 1, and 5, comma 2. And we absolutely end up with that same idea of a sideways parabola. Remember, we also talked about the fact that because we are just switching the x and the y, if we have that line y equals x, which is this line right here in blue. Again, you don't have to graph it, just showing you a visual that my two parabolas, the pink one and the turquoise one, when I fold them over that blue line, every point is going to match up. Now I do want to take this just a step further for you for just a minute to kind of tie in the lesson we did for part 1 and this lesson that we're doing for part 2. So real quick, if you can go back and look at this inverse with me that we got, we had that y equaled plus or minus the square root of x minus 1. So I have a positive one of these, and I have a negative one of these. Now let's just talk. Earlier we learned how to graph the square root of x. We said that we can identify the h and the k. We have what's called our starting point, and then our graph is going to go up and over. It's curved. It looks something like that. We're plugging numbers in that allow what's underneath the radical to be perfect squares. So if we go back to Hayavas and talk about transformations, we have a horizontal translation because the minus 1 is underneath the radical. We're going to deal with the opposite of what we see. So we see a minus 1. It's really a positive 1. So this tells me that this picture right here would move over 1 unit to the right, and that's all that would be different. It's just we're taking a shift. We're moving it over 1 unit to the right. But this negative 1 is going to have two things that happen, because not only are we going to take that original orange graph and move it over to the right 1, but the negative out front also gives us a vertical reflection over the x-axis. So it flips it. And so that's why we're ending up with that parabola that we got, the sideways parabola, because that's what's going on with that inverse function. So you actually could graph this based on your knowledge without having to create that table of values if you wanted. So a couple of ways you can kind of check your work. All right, so let's move to example number 5 real quick. I just want to check and make sure my phone is working because I'm probably going to cry if it's not this time. Oh, it's still going. Yay, I might still cry tears of joy and happiness. All right, example 5, here we go. We're going to switch the x and the y's. So we have x equals y squared plus 3x minus 4. No, just kidding. That should be a y. Whoops. 3y minus 4. Here we go. All right, quadratic. We got to get 0 on one side, so I'm going to subtract the x. Moving on over. Not sure what happened there. So I have 0 equals y squared plus 3y minus 4 minus x. Let's talk about a, b, and c. A is your coefficient of your y squared. So for us, that means that A is going to be 1. B is your coefficient of your y to the first power, so we have a positive 3. C is going to be everything that's left. Remember that represents your constant, and so we have left a negative 4 minus x. So let's plug into the quadratic formula. So we're going to get opposite of B. So I'm plugging in a negative 3 plus or minus the square root of B squared. So I'm plugging in a positive 3 minus 4 times A. I'm plugging in a 1 times C. I'm plugging in the negative 4 minus x. And then all of this is going to be over 2A, so 2 times 1. All right, so let's do some simplifying. We have negative 3 plus or minus the square root of, let's talk for just a moment. 3 squared turns into 9. Then I have the negative 4 times 1, which is negative 4, and that number needs to get distributed to the negative 4 minus x. Now, if you remember in the last problem, I saw that, and I said, hey, let's just distribute the negative sign because we already had a 4 out there. I'm not going to do that this time, and let me explain why. Because in the last problem, this value right here for b squared was a 0, so there wasn't anything there. This time there is something there, and we're going to end up having to combine like terms in a moment. So I do need to go ahead and distribute that negative 4. So negative 4 times negative 4 is positive 16, and then negative 4 times negative x is positive 4x. And then all of this is still over 2. So if I look underneath the radical and I combine like terms, 9 plus 16 is 25, so I have 25 plus 4x underneath the radical, still having a denominator of 2. Now as you look at that, you'll notice there's no GCF because 25 and 4 don't have anything in common, which means there isn't a factor that I get to take out. So there's no taking anything out of the radical. You might be wondering, why don't I get to take out a 5? Because 25 is a perfect square. And you're right, it is a perfect square. The problem is that 25 isn't a factor. Remember, factors mean what have I multiplied together. And that 25 is not being multiplied times the 4x, it's being added to the 4x. So because it's not a factor, I don't get to take out that perfect square of 5. And so what I have left is just this. There's nothing that I can do with that to simplify it any farther. And so that right there is the inverse function. So hopefully you were able to follow along with that. Now let's talk about graphing. I'm going to go back to the original here. So I have, let me give myself a little bit more room. I have y equals x squared plus 3x minus 4. So I'm in product chart, I'm going to go ahead and factor that. That's going to turn into x plus 4 and x minus 1. Remember, we're going to set those equal to 0 because that's going to give us those x-intercepts. So we're going to have an x-intercept of negative 4, and we're going to have an x-intercept of positive 1. Now let's remember, what does it mean to be an x-intercept? That means where it crosses the x-axis. And anytime something crosses the x-axis, it has a y value of 0. Because remember, we said each of those equal to 0 in order to solve for x. So that means we have negative 4 comma 0, and we have 1 comma 0 already. So let me go ahead and label my axes. I'm going to actually plot those points as well. So I have negative 4, 0, and I have positive 1, 0. And I'm going to plug some numbers in between those two. So I was at negative 4 and positive 1. I'm going to plug in a negative 3 and a 0. And I'm going to go to the factored form because I just find it easier that way. So follow along with me. I'm going to start with a negative 3. So negative 3 plus 4 is 1. Negative 3 minus 1 is negative 4. So I have 1 times negative 4, which is negative 4. If I plug in the 0, 0 plus 4 is 4. 0 minus 1 is negative 1. 4 times negative 1 is negative 4. All right, so I have negative 3, negative 4, and I have 0, comma, negative 4. All right, I already know it's going to be a parabola, but let's keep going inward. So now I'm going to plug in a negative 2 and a negative 1. So again, I'm going back to factored form. Let's start with a negative 2. Negative 2 plus 4 is 2. Negative 2 minus 1 is negative 3. So 2 times negative 3 is negative 6. Now I'm going to plug in the negative 1. Negative 1 plus 4 is 3. Negative 1 minus 1 is negative 2. 3 times negative 2 is also negative 6. So I have negative 2, negative 6, and negative 1, negative 6. Well, I do know that it's going to be a parabola, but I kind of really want to know how far down is that graph going to dip. And I know that it's going to occur smack dab in the middle of those x values of negative 1 and negative 2. So I'm going to plug in a negative 3/2. Now you can change it to a decimal if you like, but you guys know I love fractions. So I'm going to plug that fraction in. Probably not going to do that in my head, so I'm going to just come over here and show my work. We could do factored form, or we could go back to the original. I'm just going to go back to the original. So I've got negative 3/2 squared plus 3 times negative 3/2 minus 4. All right, when I square negative 3/2, that gives me a positive 9/4. Then 3 times negative 3/2 is negative 9/2. And then I have the minus 4. So obviously I need a common denominator, which is going to be 4. So first fraction is good. I'm going to change 9 over 2 to 18 over 2. Just kidding, 18 over 4. And then I'm going to change 4 over 1 to 16 over 4. So now I'm going to go from left to right. 9 minus 18 is negative 9. Negative 9 minus 16 is negative 25. So I get a negative 25 over 4. And I'm going to change that to a mixed number, and that means that I get negative 6 and 1/4. So right in between those 2 points, I'm going to go down to negative 6 and 1/4, and now I know exactly how far down it goes, and I'm totally missing my points. Let me try this again. Here we go. That's a nice looking parabola. All right, so now let's do the inverse. Remember, this should be the easy part because you've already done the work for the table of values. This is where we're going to take that table of values and exchange our x and our y's. So I'm going to have 0, negative 4, 0, negative 1, negative 4, negative 3, negative 4, comma 0, negative 6, negative 2, negative 6, negative 1, and then lastly, negative 6 and 1/4, comma, negative 3/2. If you want, you can change that to negative 1.5. And let's plot some points. So we've got 0, comma, negative 4, 0, comma, I'm sorry, that should be a positive 1. Let me correct that. 0, comma, positive 1. I did correct it in my table. That's a positive sign. All right, we have negative 4, negative 3, negative 4, comma 0, negative 6, comma negative 2, negative 6, comma negative 1, and last point, negative 6 and 1/4, comma negative 1.5. And again, we're getting the sideways parabola. And just a reminder, if you were to draw the line y equals x and fold your paper over that line, all of your points from your 2 parabolas are going to match up. Okay, so last example, praise the Lord, whoop whoop. And this is the easy part actually. We're just going to evaluate, so we're just doing some math. We're going to start with the radicals here. So we're going to break them down. So here we have the cube root of 27. Remember, that just means what number times itself 3 times is 27, and the answer to that is 3. And we're going to take that answer, we're going to still multiply it by the 3 that's on the outside, and then we're going to subtract 5. So now we're going to do the order of operations. Multiplication comes first, so 3 times 3 is 9, and 9 minus 5 is 4. All right, letter B, we're going to start inside those parentheses. The cube root of negative 64, what number can we multiply times itself 3 times to get negative 64? That answer is negative 4. We still have the exponent of 2, we still have multiplication of 2, we still have plus 7, and now we're going to do order of operations, which says exponent needs to come first. So negative 4 squared is 16. Then we get to multiply. 2 times 16 is 32. And 32 plus 7 is 39. And that's our final answer. All right, letter C. Again, starting with the radical. The cube root of negative 8 is negative 2. We're going to still have to multiply that by negative 6 and then subtract a 2. So we're going to go with the multiplication next. Negative 6 times negative 2 is 12. And 12 minus 2 is 10. All right, last one. Can you feel the excitement? Here we go. Cube root of 216 is 6. Still have the exponent, still have the multiplication of 4. Now we're going to take care of that exponent. 6 squared is 36, and 4 times 36 is 144. Okay, well, it's been an exciting Saturday night with y'all. It's definitely after 8 o'clock, and I'm hanging out here doing videos. If I remember correctly, you have a worksheet for this. I just want to encourage you guys, let me know where you're struggling. So go to the website, go to the blog, ask me some questions. You can always send me an email. I do want to encourage you, I don't even remember if I said this in the last video, but as I'm sending you back feedback from the assignments that you're turning in, take the opportunity to make corrections and send them back. Because when you send it to me the first time, I am putting a grade in my grade book, but if you send it back to me with corrections, I'm erasing that grade and putting a new grade. So you have the opportunity to earn points back. You can get a 100. I just need you to make the corrections and send it back to me, because if you don't, I'm going to leave whatever grade I had in there the first time. I hope you guys are having a much more exciting Saturday night than I am, but also let me know if you guys think we need to do a Zoom video where we get together during our class time and talk about some things. I'm up for that. I just need you guys to let me know, and I will see you guys either on a Zoom chat or in the next video. Bye.